Hello educators, I'm Daniel Mannion and welcome to our session on mastering calculator strategies. Today we'll demonstrate how to use both the TI-84 Plus CE and Desmos graphing calculator to solve a system of equations by graphing. We'll cover the steps to solve systems of equations by graphing using both calculators, and then we'll work through a few example problems to showcase these strategies. Additionally, I will give a few pointers different than the main calculator method students can use during the example problems. Let's start by solving systems of equations using the TI-84 Plus. With this tutorial, I'm making 3 assumptions about your students. 1. That they know what a solution to a systems of equations is and how to identify that. 2. Your students know how to convert equations to slope-intercept form. There will be some problems where the equations that are given are not already in slope-intercept form, and your students will need to convert them first because both the TI-84 Plus and Desmos cannot graph equations that are not in slope-intercept form. And last, that your students can write equations from a given scenario. Now, typically, these are the most challenging questions, and we'll take a look at one example of these. Not all of your students will master writing equations from a given scenario, but that's ultimately our goal, that all of your students can do those 3 skills. Here, we'll begin with the instructions for solving a system of equations using the TI-84 Plus. For step 1, turn on the calculator and access the y equals menu. Make sure that your calculator is on, and I'll press y equals to access the function editor. 2. Enter the equations into the calculator. For this example, my 2 equations are y equals 2x plus 3 and y equals negative 1/2 x minus 9. In the y1 field, I'll enter 2x plus 3. And in the y2, my second equation will be a negative 1/2 x and then minus 9. In step 3, press the graph button to display the graphs of the equations on the coordinate plane. So let's actually get a view of what our system looks like. So here's our line 1 and line 2. 4. Find the intersection points. This is where your calculator really comes in handy. We'll press second and then trace to open the calculate menu, and then we're selecting option 5, intersect, to find the intersection. The calculator will prompt you to select the first curve, which would be y1 in our case. I'll press enter. The calculator will then prompt us for the second curve, which is of course y2. I'm on there, so I'll press enter. And then last, move the cursor closer to the intersection point using the arrow keys, and we'll press enter one more time. So as I'm following along that line, somewhere close by to that point of intersection, I'll leave it and then press enter one more time. And last, the calculator will display the coordinates of our intersection point, or the solution. And so that's step number 5. Let's actually interpret that. So our solution is negative 4.8 and negative 6.6. We can verify or double check that that intersection point is our solution by substituting the x value and the y value back into the original equations to ensure they satisfy both equations. In our case, because our equations were written in slope-intercept form in the very beginning, we'll look at the second option, which says that we'll just substitute our x value into the equation and then verify that our result is our y value of negative 6.6. So let's test that. I'll go to second quit, clear that, and let's double check our intersection point is our solution. We'll start by writing, we have 2x plus 3 as our first equation. So I'll start by 2 and then I'm substituting the x value that we got for our solution in. So that was parentheses replacing x with negative 4.8. And then we'll continue the rest of the equation, which was just plus 3. And that gives us negative 6.6 as our y value, which does match our solution. Let's do the same for the second equation. Negative 1/2 x minus 9 for that right side of the equation. Negative 1/2. Now parentheses substitute negative 4.8 as x, and then minus 9 to continue the rest of that equation. We'll press enter, and that is also negative 6.6, giving us that y value. So I've now verified that our solution is negative 4.8 and negative 6.6. Let's switch on over to Desmos to give you instructions on how to solve a system of equations. Now, I'm making the same three assumptions, and again, in Desmos, we'll need to graph in slope-intercept form because of our testing restrictions. Some of your students and you probably know that we can graph in standard form in Desmos. So 2x plus 3y equals 7, and that's my linear function shown. But if I go to, again, our testing platform, and here I'm in an example test. If I click on calculator and I go to our Desmos graphing calculator and I try that same equation, I now have an error which says that plotting implicit equations and inequalities is disabled. So we'll need to convert all of our equations to slope-intercept form in order to graph during our state testing. Let's begin solving an example. Step 1. Access Desmos Graphing Calculator. Open your web browser and go to Desmos Graphing Calculator, like I have, or open up your Desmos app in your testing software. 2. Enter the equations into Desmos. For this example, we'll use y equals negative 2x minus 1 and y equals negative 1/2 x plus 5. I'll type both of those equations in, beginning with y equals negative 2x minus 1, and our second equation, y equals negative 1/2 x plus 5. Notice that as I was typing, most of my equation ended up in the denominator, so I'm going to backspace on that and then make sure that my equation actually matches what I'm supposed to type. Then press enter. Now, step 3, Desmos will automatically graph those equations as we enter those, as you see. And step 4, let's actually find that solution. So find the intersection point. So we'll look at the graph, and Desmos is quick and easy. We'll simply click on that point, and it'll give us the point of intersection. So we can see that interpreting our solution with that point of intersection, we know that negative 4, 7 is our solution to the system of equations. So for 6, we can just do a quick double check and verify that x equals negative 4 and y equals 7 is a solution. We were given both equations in our slope-intercept form, and so I can do a quick calculation here, or I can say again, that was negative 2 beginning with our equation 1, and I can say instead of x, we're going to input negative 4, and we're going to complete that equation by just saying minus 1. And we get a value of 7, which matches our y value of 7 for the solution. Great. I can also do the same in our second equation, negative 1/2. And we're going to replace x with negative 4 as well, and plus 5. We also get a result of 7, so that means that negative 4 and 7 is the solution to this system of equations. We'll now take some time to review 3 Algebra 1 star exam problems using this newly learned skill of graphing systems of equations to find solutions. We'll use both the TI-84 and Desmos to complete these problems. Let's take a look at example number 1. This is what I would call warming up, or again, level 1 type of question for solving a systems of equations. It simply says, what is the solution to this systems of equations? I said it was level 1, but notice that our equations are in standard form. What really makes it a level 1 question is that your answer choices, 1, are given to you, and 2, are ordered pairs. You're given both the x and the y value. If you take a look at this table over here, notice that the correct answer is B. And for the students that took this state exam, 68% of them got this question correct. Level 1, I'm really aiming for 100% of students in my class to be able to answer this type of question. So, how would we solve it? 1, just go through our normal kind of pathway. We said, 1, if your equations aren't in slope-intercept form, convert them, which we will. Then we'll graph them and find the point of intersection. Right after that, I'm going to show you probably the quick and easy way that your students are really going to solve this problem. So to begin, let's take a little bit of time and I'm going to convert both of these equations into slope-intercept form. Okay, both equations are now in slope-intercept form by isolating our y value by using inverse operations. And then I'm now going to graph both of these equations into our TI-84 in order to graph and find our point of intersection. So for our first equation, that is a 3/5 x plus 21/5. And for our second equation, that is y equals 6x plus 15. Going ahead to graph, and then we'll find our point of intersection by going to trace and intersect. Yes, that is our first curve. Our second curve, there we go. Yes, I can see it's on the red line. And then moving our cursor closer to our point of intersection has that our intersection is at -2 and 3, which is matching answer choice B. Okay, so that's one way to arrive to the answer, and we can verify. And it's actually that verification method, which is probably where most of your students are going to go first. Knowing that there are 4 answer choices with all of our x and y ordered pairs, students can do a simple guess and check by plugging in each answer choice to verify that it makes both equations true. So, I'll show you how to do that on your TI-84 Plus. A quick review. I'm only going to check B. I know that's the correct answer, but how could we kind of guess and check this? I want to store -2 as x and a y value of 3 in my calculator. To do that, you'll type in your number first. So, for example, -2. We'll click STO, or your store button, and I'm going to click X to save x as a value of -2. I'll do the same for y, so 3 storage, and then I need to click the alpha button, and then 1 for my y, and hit enter. So now I have x and y stored as those 2 values, and I can verify that my solution is correct by typing in the left-hand side of our equation to verify that it's equal to the right-hand side. To begin, that's -3x plus 5y, and that gives me a value of 21, which matches. Additionally, 6x minus y is negative 15, which again matches our second constant. So, through that verification, I know, without a doubt, our answer is negative 2, 3. Let's take a look at our second example. This is question 52 from the 2018 Algebra 1 STAR exam, and it states, what is the x value of the solution to this system of equations? Now, this is a level 2 problem. Again, not because of the equations that were given, but because of our answer choices. Notice that our answer choices are only given as possible x value solutions, or pieces of the solution, but we're not given any y values. This means that we do need to do the legwork of converting to slope-intercept form, graphing, and finding that point of intersection. And for just a little data analysis, according to this table, notice that in 2018 at the state level, 61% of students were able to correctly identify that H will be the correct answer choice here. We'll need to begin by converting both equations into slope-intercept form so that I can graph those in Desmos and then find the intersection for the solution. I'm going to go ahead and take a moment to do that now. The hardest part is out of the way. I've converted both equations into slope-intercept form. I'll take both equations now and enter those into Desmos to find that point of intersection, which is our solution. Y equals 1/2 x plus 2, and y equals negative 7/5 x minus 66. I'll make sure that our solution is in our field of view, and in order to find that solution, we'll just simply click on that point of intersection, and we can see we have a solution to the system as a negative 8 and negative 2. So I'll write that down. Negative 8, negative 2 as our solution, and we would only like the x value of our solution, and so looking at that ordered pair, when I'm labeling those, that's x equals negative 8. So our answer choice would be H. Like before, since our equations are given to us and I know that my solution should be negative 8, negative 2, we could verify that that solution is correct by plugging both our x and y value back into both original equations. Last, let's take a look at question 40 from the 2023 Algebra 1 STAR exam. This I deemed as level 3. Yes, it's level 3 because, one, we're not given the equations. We're going to need to write those, and that's a major challenge for a lot of our kids. And two, the answer choices, again, it's not an ordered pair. We're given just one of either the x or the y coordinate values, and we need to do a little bit of work in order to make sure we're selecting the correct answer. So, taking a look at this, I wanted to point out that up here at the top, there is an exclamation mark. This was deemed by Lead Forward as an interesting item. They say, what can we learn from this item to inform instruction? Notice that according to our data analysis, that only 31% of students were able to answer this question correctly, with the next highest answer choice being C at 27%. To be honest, this looks like probably most students guessed, and there is a little bit of higher percentage for D, as the correct answer, because of course there are a group of students that were able to solve this correctly. Now, what can we do to increase this percentage and have students learn and be able to write these equations? It is going to take practice. I'm going to go through how I would typically model this type of problem in my classroom, and you should strategize ways that you're going to introduce and practice these types of problems in your classroom as well. For question 40, I'm going to model a teacher think aloud. So let's put the teacher hat on and begin. Class, today we're looking at question 40, and we're going to write a system of linear equations and then solve using our calculator and or Desmos, of course. So first, I've got to read it. Let me see how this problem goes. It says, a company advertises on 2 websites. Okay? Each website charges a different amount. Let me get my draw tool here. Each website charges a different amount based on the number of clicks on the advertisement. That sounds important. I know that each website is going to charge a different price based on the number of clicks on the advertisement. Okay, then the table shows the number of clicks on each website and the total cost for each of the 2 days. So I know that website 1 charges one amount, website 2 charges a different amount per click, but all said and done, it's still going to add up for my total cost here. Okay. What's the question asking? It says, what is the cost per click, but specifically for only website 1? So that's what my answer choice is. I'm just giving like one value. Alright, it's looking like a system because I'm seeing 2 relationships going on here. I'm not given an equation, so I'm going to have to write it. Now, I'm given a total that usually means slope-intercept or standard form. And because I'm given 2 different variables, like website 1 cost and website 2 cost, this is really screaming at me as like standard form. The ax plus by equals c. So I'm going to try that. Now, each website charges a different amount. That means I need to define my variables, right? So if we're starting with website 1, so I'm going to let x, this is my first variable, and I'm going to define it to be, this is going to be the cost. So I'm just going to write money, my money sign, cost per click, or c. And this is going to be specifically for website 1. So I'm just going to write a 1. Cost per click for website 1. And I'm going to let y, my other variable, this is also going to be a cost per click, but this is going to be for website 2. With those variables defined, I can now write my standard form equation, which means I'm just going to take, I know that 15 clicks for like website 1 times the cost per click plus the 29 clicks from website 2 and that other cost, or times that other cost. If I take both of those costs together for website 1 and website 2 for that day on Monday, let me go ahead and undo that, then I should get a total of $94.15 for that cost. I'm going to employ the same logic for the second equation. So for Tuesday, I know on that day there were 25 clicks, and we'll of course multiply by the cost per click, plus for website 2, it's actually the same amount of clicks for Tuesday at 29. And my new second total is $121.15. Okay, I've got both of my equations. So now I need to convert these equations into slope-intercept form. I've got to see the graph and find that point of intersection. So I'm going to take a moment and write both of these equations in slope-intercept form. Alright, again, the hardest part is done. I've converted both equations into slope-intercept form. I'm now going to graph the system of equations. So y equals negative 15 divided by 29x, and then plus 94 15 over 29. So it's my first linear equation. And for the second, y equals negative 25 over 29x plus 121 and 15 divided by 29. Okay, both of my equations are graphed, and so I can see the system that there is a solution here. I'm going to zoom in a little bit for Desmos, and I'm looking for my solution now. So I'm going to go ahead and click on that point of intersection, and we can see that my solution for the system says we have 2.7 and 1.85. So if this is a solution to our system, I need to go back and look at my answer choices in the question. It says, what is the cost per click for website 1? Now, going back to our variables, I assigned x as the cost per click for website 1. And so that means when I'm looking at my coordinate pair, of course, I am really, looking at just that first value, x equals 2.7, and not the y value. I don't really need to be looking at that. But I'm going to bring that back. I don't want my solution to go away. So that means that the correct answer for us to choose would be D, that $2.70 for this system of equations. Today we learned how to use both the TI-84 Plus CE and Desmos graphing calculator to solve systems of equations by graphing and finding the points of intersection. We also worked through a few example problems detailing different levels of complexity and what students might do additionally in order to help find the answer to their problem. So, thank you for joining me today. Practice more problems using these strategies with your students so that they become more comfortable with using these tools. And again, thanks for watching and happy teaching.